So given this graph, we want to write a fourth degree polynomial that also passes through the point 6, 16. So let's identify our zeros. We got one here at -4, we get one here at 2, and we get one here at 5. So just based on those zeros alone, we can start to write this thing in factored form. So f of x, so if -4 is a 0, x plus 4 is a factor. If 2 is a 0, x minus 2 is the factor, and finally x minus 5. Now, we always want to have an a out front. That's what's going to help it go through this point, or we could use the y-intercept, whatever point you're given. But before we do, we need to check to see if any of these are repeated. If they go straight through, like these ones, they're not repeated. If it hits and bounces off, it's repeated an even number of times. So we do need to put a square on there. If it had done something like this, where it flattens out at the 0 and then keeps going, like an inflection point, then we would have had an odd power and we would have put a 3 as the exponent. Now we have to find the a, which means we're going to use this point here. The output is 16 when the input is 6. So let's go ahead and set that up. So all I did was put in 6 for x and 16 for y, or the output. So 16 equals a. We have 10. This will be 4 squared, which is 16, and this is 1. So we have 160a, so 16 equals 160a. Divide by the 160, and we're going to get a equals 1/10. So our polynomial for this that would give this exact graph is 1/10, and you can just leave it in factored form. Always leave it in factored form unless you're told explicitly to do otherwise. There is our polynomial, and you can always graph it in your calculator to check.